Hi, grade 6. This is part 2 to my part 1 video for 6-4 direct proportions. Okay, so I did the first video and then it timed me out. So I just wanted to go over a few more examples with you. So I left off on workbook page 173. I did example 1 at the end of video 1. So now I just want to cover a couple more examples for these workbook pages. So I'm going to do number 5 with you right now. Okay, number 5 says, for each pair of triangles, write a proportion that shows that the ratios of the base b to the height h are the same. Use the cross products rule to solve. Okay, so this is what you see for number 5. Alright, and again, we're not actually solving this. They just want you to set it up as a proportion, and then you can use the cross products rule to check your work. Okay, so they want you to set up a ratio of the base b to the height h and show that they're the same here. Okay, so to do that, this here is my base. See it? Base is the bottom of your triangle. Alright, so they want to set up a proportion that is base over height equal to base over height. Okay, so super easy. What's my base here? 60. Right, and that's over my height, which is 40. And that's going to be equal to my base, 36, over my height, 24. And then they want you to use the cross products rule to prove that these two are equal, or to prove that they're a proportion. Okay, so over to the side here, I'm just going to do that for you because I'm running out of room. So we're going to use, again, the cross products rule to prove that these are equal. So the question is, does 60 times 24 equal 40 times 36? Okay, 60 times 24, does that equal 40 times 36? So when we multiply these out, 60 times 24 equals 1,440. Okay, and then 40 times 36 also equals 1,440. Okay, if you notice in the book, they have both of these flipped. They did height over base equals height over base, which I don't know why they did that, because it said base to height. They wanted a base to height ratio, not a height to base, but whatever. If you were to set it up like this, okay, it's no big deal. You're just going to have 40 on top and 60 on the bottom over here, and then over here you're going to have 24 on top and 36 on the bottom. When you multiply that, you'll notice 40 times 36, that's here, 60 times 24 also here. You're going to end up with the same answer. 1,440 is equal to 1,440. Okay, so your answer for this is here, and then here's your proof using the cross products rule that they are proportional. Okay, the top of workbook page 174 says, average speed is the unit rate in a proportion involving distance and time. Write a proportion to find the missing average speed. Super easy, you guys. Okay, so here it just says, at what average speed can a locust fly if it can travel 46 meters in 5 seconds? All right, so what we're looking at here is just meters over second, and you're going to remember that unit rate always has 1 in the denominator. Okay, so meters per second. When I set this up, then it's going to be 46 meters in 5 seconds. Okay, we want this equal to what? How many meters per second, per 1 second? Okay, that's the unit rate. All we're doing, you guys, is dividing 46 divided by 5. That's all that's happening here for these problems, okay? But to prove this to you, if you set this up as a ratio, meters per second equal to meters per second, I have 46 meters for 5 seconds. It's asking you at what average speed can a locust fly? So an average speed is just a unit rate. You're just dividing 46 divided by 5, okay? What we're actually doing here, how do I get from 5 to 1? Divide by 5. So therefore, how do I get from 46 over to my missing value here? I'm dividing by 5. Alright, so again, unit rate, you're just dividing. You guys already took a quiz on this. You divide top to bottom. So 46 divided by 5 gives you 9.2. Alright, so a locust can fly at a rate of 9.2 meters per second. Okay, whenever we have per second here, that's the unit rate, per 1 second. We just don't say 1, right? So your answer here is 9.2 meters per second. Okay, numbers 11 to 13 says, the graph of a rate is a straight line. Write each exercise as a rate. Then express the rate as an ordered pair. Plot the coordinates on the graph. Okay, so number 11 says $15 for one shirt. So what I want you to notice is that on the graph on page 174, you have t-shirts as your x coordinate, right? T-shirts are on your x-axis and the cost is y. That's almost always the case. Cost is always going to be your y coordinate, okay? So what we're looking for here, right, again, an ordered pair is xy, okay? So if, again, x here, when you look at that graph, x equals what? Number of shirts, okay, that's a shirts, and y equals cost, okay? So, keeping that in mind, right, the first thing I want to do is write my rate. So, this says $15 for one shirt. We're going to write the rate exactly like that, 15 to 1. So that's my rate, $15 for one shirt. My ordered pair is written as x comma y. So what do we say x was? X is the number of shirts, so that's 1. And then my cost is always y, so that's 15. Okay, and again, the reason why I set it up like this is because I look at that graph that they gave us, and the graph on page 174 has my x-axis, right? That's the horizontal line on the bottom, says t-shirts, and the y-axis says cost per t-shirt. So x is number of shirts and y is cost. And therefore, you're going to write this as 1 comma 15, not 15 comma 1. Okay, 15 comma 1 would tell you 15 shirts cost $1, and that would be incorrect. Okay, so this is number 11. I hope that was helpful. Then you guys are going to try the problem solving on your own. I'm not too worried about those. Number 15 you should be able to do pretty good. Okay, but I want you guys to try that on your own. I just want to go over one more problem. It's on textbook page 155, the try these number 1. So it's really important that you understand this. Okay, so I just finished up the workbook pages with you, so hopefully that helps to clarify what it is that you need to do in the workbook pages. I'm just going back to textbook page 155, and I'm doing, from the try these problems, I just want to do number 1 with you. This is really important to understand, you guys, okay? So, number 1 says, a sample of paint contains 3 ounces of blue paint and 8 ounces of yellow paint. If you have a 24-ounce can of blue paint, how much yellow paint should you mix with it in order to make the same color as the sample? So guys, Lowe's, Home Depot, your local hardware store that sells paint, okay, they have to use proportions all the time. Pretty exciting, huh? So, alright, we have 3 ounces of blue to 8 ounces of yellow would equal 24 ounces to blue given how much yellow. So we're going to set this up. I'm going to set up my proportion. Again, I like to do unlike quantities, so I like to do blue over yellow equals blue over yellow, as opposed to blue over blue equals yellow over yellow. Know what I mean? So I could set it up like this. Blue over blue equals yellow to yellow, and that would be like quantities for a direct proportion. I don't like to set it up like that, so I'm going to do blue over yellow, that just makes more sense to me, is equal to blue over yellow. Okay, and now I'm just going to fill in. So, blue to yellow, right, what do I have here? I have 3 ounces of blue, 3 ounces of blue over 3 ounces of blue over 8 ounces of yellow, and that has to equal what? 24 ounces of blue for how much yellow? So this is how I'm going to have it set up. And again, you want to label it, so 3 over 8, right? And then I'm replacing 24 blue, so 24 goes on top. And then my unknown is my X or my yellow here. Okay? So make sure it's super important that you put 24 on top here because that's blue, right? 24 blue over my unknown is my yellow on the bottom here. This is where kids get messed up. You guys end up reversing these on me and you get the wrong answers. So you want to label and make sure you fill in appropriately. 3 ounces of blue, so 3 on top, 8 yellow, 8 on the bottom, equals 24 blue, 24 on top. How much X? That's my unknown. So how much yellow? That's my X. Okay, that's going to go on the bottom. So now you're going to use the cross products rule to solve this. So I'm going to do 3x equals 8 times 24. Okay, so I'm going to set that up over here. So I have 3 times x Oh, I need new markers. Okay. 3 times x equals 8 times 24. Okay, when I multiply 8 times 24, I get 192. And then that leaves me with 3x equals 192. 3 times x, so I need x by itself. I'm going to divide both sides by 3. And when I do that, I get x equals 64. And again, you guys, I'm allowing you to use your calculator to solve these. You guys see that? There we go. X equals 64. See it? Okay, so what that means is you would need 64 ounces of yellow paint if you have 24 ounces of blue paint in order to get the same color as the original sample size of 3 ounce to 8 ounce blue to yellow. Alright, so again, x here equals 64 ounces of yellow. Alright, so I hope this video was helpful to you guys. Feel free to watch both videos a couple of times. Alright, and if you have any questions, just let me know. Have a great day. Take care. Bye.